This is going to be a flip video about predicting products for chemical equations. Specifically, we are starting with synthesis and decomposition equations. So let's take a look at what synthesis means as a refresher. Synthesis is when you have some sort of a substance and another substance coming together to form one final product. So if we look at this, A reacts with B to make AB. A lot of times we have an element reacting with another element to make a compound. So in other words, separate things come together. You have the separate things as your reactants, and you have the coming together as your products. Okay. Now, let's take a look at our first reaction. If you notice here, I've given you reactants, like I will always give you, and you now need to predict the products, so the back end is missing. So I want sodium and chlorine to react together. When sodium and chlorine react together, they're going to make one final compound. So the first thing I need to do is realize that this is synthesis. And how do I realize this is synthesis? Well, I take a look at this and say, okay, I have a single thing here, so we could pretend like this is A reacting with a single thing here, B. A, B. A and B are going to come together and make AB. So the reactants help give away that this is a synthesis reaction. A synthesis reaction. Okay? Now, when these two come together, you have to remember to write their charges and balance out their charges. So we're kind of going back to the old thing about how to make a compound. Anytime two things come together, you want to make sure that you've balanced out their charges. So if we notice here, we have Na positive and Cl minus. I need one of the positives and one of the negatives, so my final product is going to be NaCl. Now, you might be asking, how come this 2 isn't over here? Remember, this 2 is only here because chlorine is all by itself. Chlorine is one of our 7 diatomic molecules. When chlorine is by itself, it needs the 2. How come it doesn't need it over here? Because it's about to bond with sodium. So therefore, it's not by itself. So don't carry over the subscripts. Instead, we are going to charge balance and make our new subscripts if we need them. One sodium and one chlorine balance out to make NaCl. The last thing I have to do is balance. So I have 2 chlorines here, put a big 2 here, and a big 2 here. 2 sodiums, 2 chlorines. Okay, let's see another reaction. In this reaction, instead of giving you the formula, I've made it a little bit trickier and I've given you words. So you have to first start off by writing formulas. So magnesium, well, that's easy. That's just Mg plus bromine. Okay, well, we have to remember bromine is also another one of those 7 diatomic molecules. Bromine, Br, is all by itself, so it needs the little 2. Magnesium is not one of the 7, so it gets written just like you see on the periodic table. Yields. Now, how did I know that this was synthesis? Because I notice I have a single thing here. We'll label this like an A and a B. I have 2 single things, and they're going to come together to make the final product. That's what synthesis is. In order to do that, remember, you have to make sure that whenever 2 things are coming together, you have to charge balance them. So let's look on our periodic table and see if you remember the trends. Magnesium is in column 2, so it gets a 2+. Bromine's in the 1- column. I'm going to need 2 of these to balance out one of these. So Mg, Br2. Okay, don't forget. So right here, it's important up on the top to write your charges. They don't go in your equation. There is the work done up on the top. So we'll call this showing your work. don't forget to please show your work, but remember, don't include it in the final equation down here. Last thing is, let's see if this is balanced. 2Br, 2Br, 1Mg, 1Mg, balanced. Okay, now that we've done synthesis, what is decomposition? Just a quick refresher. Decomposition is the opposite of synthesis. So now decomposition is when you have something that's like complex, a clump, that breaks down into more simpler things. So AB breaks down into A plus B. It can even break down to more things. It's just breaking something down. You always start off with one clump of something. So something that's more complex, breaking down into something that's simpler. Okay? So the hint is, look for one thing as your reactant. All right, so let's take a look. One thing as my reactant. Here we go. Decomposition. One thing as my reactant. If I notice sodium is bonded to chlorine, so this is an AB stuck together. Decomposition. I want to then break it apart into simpler elements. I'm going to just break it into its elements. Now, I don't need charges. I don't need to charge balance because things aren't coming together. They're breaking apart. So I just need to break this into its basic elements. For decomposition, the only thing you have to worry about is Hankel-Brief. So sodium is not part of the 7 diatomic molecules. Remember, Hankel-Brief helps you remember that. Let's bring that in really quickly, maybe as a refresher. Okay. These are my 7 diatomic molecules. Push this up here. Hydrogen, oxygen, nitrogen, chlorine, bromine, iodine, and fluorine. When they're all by themselves, they need the 2. So I bring that up because I'm about to separate chlorine out and decompose, break it down. I'm breaking sodium apart from chlorine. Is chlorine one of the 7 diatomic molecules? It is. So, and it's all by itself, so it's going to need the little 2 there. You have to remember to put that in. So the only thing you have to worry about for decomposition is breaking apart and do you have a diatomic molecule? You don't have to worry about charge balancing. That would be good to write down. Charges are only needed when things come together to balance them out. So if you notice, AB broke up into A plus B. That's the format for decomposition. Okay, let me go a little bit harder, and this time I'm going to show you the words. Anytime you're given the words, you have to write the formula. So let's write this formula. Remember our last chapter. Remember, when you write a formula, you want to make sure that you use the charges. So let's look up calcium and chlorine. Always, you need the charges whenever you write any formula. Calcium on your periodic table is in the 2nd column, so it gets the 2 plus. Chlorine is in the 1 minus column. So I'm going to need 2 of these chlorines to balance out the 2 plus on this side. So when I write this final formula, I'm going to have CaCl2. Yields. Now I'm ready to go, and I'm ready to break this down and decompose it. Okay? So I now have my formula. How do I know that this is decomposition? Because I start off with one compound, an A bonded to a B, one compound. And I'm going to break it down into A plus B. That's decomposition. All right? I'm just going to break calcium and chloride apart from each other. Calcium and chloride. Now, I ask myself, are any of these diatomic? And the answer is yes. Chlorine is, so it gets a 2. Now, don't be confused. This 2 did not transfer over here. It's not the same reason. You needed this 2 because of what we did here. To balance out the 2 plus on the calcium, you needed 2 of the chlorides. So that's why we wrote it. Why is this 2 here? Because chlorine is one of the diatomic molecules that can't be alone, so it bonds with another one of itself. So you have 2 chlorines. So let's make sure we balanced. 2, 2, 1, 1. Good to go. That is how you predict the products for synthesis and decomposition.